Hi, it's repair time. I've got a Tennismatic. It's an Australian company who manufacture the tennis ball serving machines. Mrs. EEVblog is a competitive tennis player. You don't want to mess with Mrs. EEVblog on the court, let me tell you. And she got a second-hand Tennismatic machine to do, practice serving. You put it on the other side of the court and you can shoot, you can program the thing, dial it in, and it just shoots it at different angles and randomizes things so you can get your bin, top spin, bottom spin, and you can your sweep speed and your elevation, and so you can just control it from the other end of the court here. And she said the machine works great, but the remote control's not working, so I thought I'd have a look at it. 9-volt battery powered here, just your regular battery snap. The leads look okay, but yeah, let's measure, shall we? First we'll do some ohms measurements and see if there's anything there. Let's have a look. Nothing. We do want to change polarity on that just in case that there's, like, the bias is not in the right direction to overcome a semiconductor junction. No. So it could be open inside somewhere, but let's see. The next step would be to check if it actually draws any power. So let's get, we'll be down in the, we'll go microamps, and we'll put it in series, and whoa, hello. There's some residual, there's something there, some residual, it's dialing back. That could be an input capacitor, but there is something. Okay, let's see if it draws any spikes. Nope. You'd expect to see a current spike when you push the battery. I don't know how much, what the transmit power it'd be. It's, using a few hundred megs or something, RF transmit. No, nothing. What? Whoa, hang on. Was that a button? Yes. Hello. 80 microamps, 90. So that button worked. Was it, I have to hold it down? Nope. So these buttons don't work. That one works. What about that one? Nope. That's interesting. That button works. That button works. That button works. Are they in a row? Is it a row column thing? Wow, it's a row column thing. Well, it's just a row thing. Wow, that's interesting. Those buttons draw something. Wow, that's fascinating. I didn't expect that. All right, let's open it up. So I can't imagine there being any other reason for that. I haven't RTFM'd. I don't even know if there is a manual for this thing. But why just those buttons? That one row there and nothing else works. That's interesting. Oy, pretty old school. This is not a new design. Oh, all the Atmel fanboys go wild. Look at this. I've got an AT-Tiny 2313. No worries. All right. Chongx caps here. Nothing fancy at all. Okay, so was that red LED coming on? There's no real strain relief there. That's a bit how you're doing. Let's push the known button. Ah, yeah, there we go. So that is definitely, that should be more than the, what is the 100 microamps or whatever, but that is flashy in. And yeah, sure enough, the other buttons don't. Hang on. There's a pin missing here, but there's a trace going to it. Has someone fiddled with the ribbon cable? Wonder, I'm going to take that off. They've put the ribbon cable on backwards. Yeah, look, there's no trace, well, there's no trace connected to the top. I'd have to take the board off. I don't know. There's a trace to it, and it's not connected, so have they, has somebody taken it off and then put it back on in the wrong location? That'd be an interesting fault, would it not? Fault in quote marks. Got our antenna up here. We've just got our little transmit module over here. There's nothing fancy at all. Literally got RF on the transistor. Geez, is that an RF transistor? I'm not sure. Is that just a coincidence? It's got RF on it. Yeah, 433 megs. Yep, that's what I would have guessed. So it seems to work. So the processor's doing its thing. But yeah, let me get this board out. There we go. I can just lever this board out. So let me see if there's a trace. If there's no trace going to that one, then I reckon that's what's happened. I could measure that. If you couldn't get ready access to the bottom, you could just buzz that pin out just to see if it went anywhere. Oh, is that, no, I was going to say, is that a pin 1 marker? No, it's not. Yes, there is. Okay. There's that going over to there. All right. So much for that theory. Solder joints look okay. That's manually been soldered, whereas the other looks like it's a wave soldered jobby. Nothing wrong with that. I'll just heat it up for kicks. There's actually nothing doing there at all. Just looking at that. Oh, hang on. Is that a... Oh, no, that's just a break in the plastic. It doesn't seem to be an issue there with the actual trace. Almost looks like there's an offset issue there. Okay, so we've ruled out the microcontroller. That's working fine. If we manually shorted out like a couple of these pins, we could probably get like different combinations working. So there's some reason why only a row is working. I mean, I could just try out my wild theory, can't I? See if it happens. No, the top row is working now. So nothing obvious on there, like, you know, there's no spillage or anything. There's no breakage in those traces at the bend points. You want to check out the bend points. No, those bend points look good. Don't be fooled by the shadows. We can physically see the contacts under there. Yeah, they're shifted off to the side a bit. I'm sure that's not the problem, but, you know. What I'm going to do is probe this thing and see if I can get some continuity happening. You see that there's physically two different strips there. They could be separating those into rows and columns. That'd make sense. 3 columns, 5 for the rows. There you go. Yep, that makes perfect. That's a perfect count. So let's probe across that one and that one. Like, let's just call that pin 1 of the row and column. Do this on the side of the bench here. Sorry, you can't see it. No, I didn't get anything between that pin and that pin with any of the buttons. That looks okay. That looks pretty solid. Don't want to go peeling the stick. It's not a sticker. It's a... Yeah, it's a big, chunky, flat thing. I don't want to go peeling that off if I don't have to. Well, let's go back to the PCB here. I'll put it in current mode and we'll short between, because pro tip, you can use your multimeter as like a shorting thing. Just put it in amps mode and you basically got, you know, a couple of ohms depending on your fuse resistance plus your current shunt resistor in there. Anyway, let's see if she lights up here. Yeah, so that's a column and that's a row. Yep. Yes. Right? I can get any of these to light up. Well, yeah, that one's not connected, right? Second row, right? So if I do 2 columns, it's not going to do it, right? So there, yep. So, yeah, she's all good, right? So that micro is doing exactly what you expect it to. So the problem is the bloody membrane. That's a bugger, that the actual membrane's gone. I was hoping for an easier fix than that. I was hoping for like just a, you know, a broken battery snap wire or something like that. But, I mean, this looks pretty solid and robust. It doesn't look like it's had any water damage or anything really. You know, you'd expect maybe 1 or 2 buttons, like, and it doesn't look like it's had much use. The previous owner apparently had only used it like 4 times or something. So I don't even know if they used the remote control at all. So no signs of water ingress. It looks like a completely sealed thing. So yeah, if I peel it off, then it's just I'm not sure. I'm not sure if we're actually going to see anything. There's our contact. You can see it. We've got so many that aren't working. It's not like there's one break in there. So that's the annoying thing about this fault. These things are usually very robust. I know it's not new. What's the date code? 1434? That could be 34th week 2014. So it could be 10 years old. The actual design's probably way older than that, but 10 years old's not long enough to like degrade stuff, and it looks like it's had hardly any use at all. Is it the actual connector? It looks like they're crimped, wrapped around there. That seems pretty solid, doesn't it? Doesn't explain why so many of them. Yeah, it's definitely not, it's offset a bit, but damn, I mean, and that's why if you wiggle that, just the whole contacts are really solidly crimped onto there. So I don't see how that's a problem either. Oh, Hang on, those 3 aren't working anymore now. So that's interesting, is it not? The only row that was working is not. No, now it's working. Nope. So if I like put that on and I wiggle, 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 yeah, all over the place, still not doing the business. I can't say I've ever seen this scenario before. Like, I've seen old keypads wear out and you get a worn key or whatever through use, or they've had water ingress or something and it's rotted stuff away and things like that. And then you'll get breaks in the ribbon cables if there's any you know, movement in them at all. And maybe you could get like one bad intermittent contact in there. I've seen those, but nothing that takes out the entire thing. It's just taking out the whole keypad. Damn it. And it's a simple row column thing. And if I release my thumb, no, it still works again. Nah, and now it's gone. If I put my finger back on there, looks like it is that connector. But why only that row? Nothing else. That one row and the 3 columns work, but all the other rows have failed? So what, let's say this is the good one, is that one's failed, that one's failed, that one's failed, and that one's failed. How can I access the contacts on the surface there? They just happen to be on the inside, don't they? Bloody Murphy. I can bend that back and we can get in there and have a look at this turd. And yeah, they're piercing through. Are they soldered onto there? That seems most likely where the problem is, because the keypad, like these keypads are basically sealed things. They're like sandwiched in there and they're sealed reasonably well. I mean, you can get water ingress to them, but generally, yeah, I would expect the issue to be the crimp contacts down in there. So I can take the pins out. Yeah, there we go. Way, there we go. Got it. Let's have a closer look at this, shall we? There you go. That actually looks... So yeah, it's piercing the plastic there. My issue is that there's just so many of them. That actually looks like some solder on there, doesn't it? Let's do some buzzity-doo-dah. Okay, we're getting that. And once again, we've got exposed material here. Yeah, we're getting... That's definitely connected. Is that coming off? Oh, silver's coming off. Ah, yes. Look at, oh, I've almost Kamagutsa completely there. Is that like a silver trace? I've practically worn through that thing. Oops. Is that our problem? Have these just like rotted away or something? But you saw it, we were getting continuity right up to there, where it goes into the plastic, and then after that everything looks fine, right? I mean, there's no issues at all. Look at that, right? But once again, there's so many like I wouldn't expect so many breaks. Have we just got like a really dodgy quality keypad here? Man, I did not expect this much trouble from a keypad. And now we've got almost all the keys are out because it looks like we've just got a poor quality keypad. Wow. Well, I'll see if I can get this one out of here as well. So I'll get back to you. There we go. Okay. Yeah, I'm getting nothing. Yeah, nothing. And I can physically scrape away, can I? Yeah, I can physically scrape away some of that. Yeah, if I can physically scrape it away, it means that it's exposed and I'm making contacts. So, yeah, these are just all dodgy. So let's just go into ohms. Nah, yeah, see? 300-400 ohms. Wow. Yeah, these are just really bad contacts to the... I don't blame the contacts, I blame the... membrane material. It's just poor. It's completely Kamagutsa. And annoyingly, I can't easily push these back on to here because they're not a complete box type. They're like an open top type. So it really requires the surrounding plastic in there to be able to push these back on, which is kind of annoying, but So what I think's worthwhile doing here is trying to get some conductive ink onto some silver conductive ink and just like spread it all across here to see if I can like make better contact. Now, the only stuff I've got is this circuit scribe. Came in the mailbag donkey's years ago, I think, so I'm not sure like shelf life, but beta. The whole point of this is you can actually repair, probably should get some gloves on. You can actually repair stuff like this. Now, I'm not sure if that's the original consistency or not. I don't think so. I kind of remember it being a bit better than that. Anyway, I could actually try and put some on, I guess, but I think this might be very out of date. But anyway, so whether or not it like hardens or does whatever, I don't know. But yeah, nah, I think I need some good stuff, but I don't have any to hand. And I just checked JCar, which is my nearest store. They didn't have any. RS Components didn't have any. I'm at least a couple of days away. It's not pretty, is it? The problem is trying to solder membranes like these. It's just going to melt. So yeah, don't do that. That's actually that's not bad. So that's going to set. Could work. But yeah, it's so I don't know what the shelf life of this thing is. Couldn't find a data sheet. I think you get what you get and you don't get upset. Now you can see where the problem's likely to be here. You can see it looks like discoloration, but it seems to be that the silver has just worn away on that flex, even though this is not continually flexing, right? If it was continually flexing, you could think that, okay, it's going to like wear off and then little flakes would come off over time and stuff like that. But like there's nothing, like it's not being used in something that's flexing all the time, but it looks like it's sort of almost worn off. So if we flip that over so we can probe it, okay, if we go, like you can see that the plastic ends here, okay, so if we probe here and here, right, it's conductive. But if we probe here and here, it's not conductive, right? Even though on this side, if you look at the microscope on this side, you think, that's not broken. There's no break there at all, right? But we can see it from the other side. So, right, that's why, look, it's completely worn off. So there's nothing wrong with the contacts in here, right? Actually, to the crimp pins, we flip it back over, and it's that the silver has worn off because this is the bottom side, right? It's the bottom side next to the plastic. This is all plastic here, right? But we can clearly see that. It's kind of like the silver's just worn away or whatever. I don't know how. But it's like that for every single one of them. Look at that. That's crazy. Okay, so I used my dodgy silver paint, and here it is. Okay, it's dried now, and sure enough, we get continuity. And if right, 15 ohms, right? That's good enough for Australia. That's certainly going to, the micro is going to recognize that. The other one looks like, yeah, like 4 ohms, right? So yeah. So that silver paint, as dodgy as it was, worked. But since then, I have ordered it, and I've got my little silver conductive ink. I just got it from the local hobby store. In fact, the same hobby store that I originally got the Indiana Jones train set from, Hobbies in the Hills. I got it from them. They're just on eBay. They're not in the hills anymore. I think they're buggered off up the coast or something. But anyway, silver conductive paint. Haven't looked at the data sheet for it. And it comes with this very nice needle point. Look at that. Whoa, it's tiny. Yeah, I didn't want to use that dodgy stuff again, even though it looks like it kind of worked. It kind of worked. I don't know, has it cracked in there a little bit? Yeah, don't use sort of out-of-date conductive paint like that. It still seems to work, but yeah, I wouldn't trust it. Okay, I'm going to need a clamp to hold this in place because this thing just boing. Here we go. Because it's a syringe, it's not going to be the easiest thing to apply, and I've got this hanging up in the air, so it's a little bit, I got too much on the end of that, but because that one is No, it's, in fact, it's going to short to the one next to it, isn't it? So I shouldn't have done that. Maybe I should get rid of some of that. That was terrible, Muriel. Started out with way too much there. So can we scrape away? Yeah, it doesn't really seem possible to use the syringe and this at the same time. This is terrible. Oh, yeah, it spreads out way too much. Yeah, I've got to have very little of that. I'll steal some from over here and place it over here. Yeah, that's the problem with this syringe stuff. I could have like a dispenser, like a automated paste dispenser. Don't have one to hand. Anyway, we're just trying to bridge up. Like, I'm putting it over the pins, which I don't have to do. Only trying to bridge over that part that's not conductive. Should be doing an end on, shouldn't I? Yeah, this is terrible. Won't give up my day job. Yeah, I really didn't need much at all. It's not easy when it's hanging up in the air and you can't put your wrist flat on the bench. And usually you just leave these to dissolve away, like evaporate away the whatever like alcohol-y type stuff is in there or whatever. And you can usually apply some heat to them as well. My box of cotton buds has vanished. Don't know where it is. I'm not just going to go to the shop to get it, so I'll try an alcohol wipe. The glare is really annoying here, but not going to bother to fix it. And, oh, no, that's not shorted. Nope. It's a bit how you doing. Oh, I smeared it out. Oh, I smeared it out by touching the... Oh, no, I've come a gutser. Look, I accidentally smeared it out. Oh, see if I can rub that off with the wipe. Here we go. Yes, I can. Okay. Oh, it's almost as if I'm better off, like, wiping it all off and then starting again. Wipe it all off. Start again. Oh, all right. Should have been more aware of that, but oh well. Live and learn. All right, let's try that again, shall we? There we go. Look at that. That's a fat-ass trace, isn't it? Yeah, it's hard to know how much to pick up from my pile over there because it just oozed out when I pressed my syringe. Another big-ass fat trace. I don't care how fat it is. I just want it to work. Kind of like the fat-looking ones better. Don't know. It's more conductory. So yeah, you might be able to do this a lot better with a very fine automated dispenser, but it'd have to be a real fine jobby. Big fat ones are hilarious, but oh well, I'm not going to complain about them not working. Like, they look bigger than they are. They look big because of the lighting on them, but they're actually not that huge in the scheme of things. So what you do now is you either leave it there for like 12 hours, 24 hours or something like that. It depends on the type it is. Yeah, they actually use like an alcohol in there, and you can heat it up. Like if you get it to like, 60 degrees or something, you might be able to do it in an hour or something like that. So you shouldn't try and measure it now while it's wet. You wait until the alcohol or whatever thinner in it, that actually evaporates, and then you're left with the conductive silver paint. Yeah, I might put that on some mild heat to accelerate it. But anyway, that wasn't pretty, but I reckon that is going to work a treat. Actually, the interesting thing is the two I did with my other silver paint, that actually looks better, doesn't it? Looks better than this. Oh, actually, this is the one that I've done now. Is it still wet? Or is it? Yeah, she's still wet. Okay, no worries. So I've just got my hot air gun set to 60 degrees and I'm just going to blow it over that for the next hour or something, and hopefully that should be reasonably dry. Get back to you. Let's see if it's solidified. It's a little bit, yeah. Okay, maybe because that's too thick. This seems okay. I need to give it a little bit longer, but hey, let's measure the ohms. Measure that. 3 ohms. No worries. And boom. Yeah, that's great. That's great. I think we're in business unless it's degraded somewhere else further up the membrane as well, but I don't want to jinx it. You can see that one. Yeah, that one hasn't totally evaporated yet. It was too thick. Is that the same on that one? Oh no, 25 ohms. Yeah, okay. I just need to leave that one for a bit longer. There's just, yeah, just hasn't evaporated all the binding agent. Once that evaporates, then you're left with the little silver solder balls or whatever they are. So yeah, I'll give that a bit longer, but it's looking promising. Okay, I've given it some more time, and hello, 12 ohms, no worries. I think that'll get better. It's still a bit spongy. 6 ohms, yeah, no worries. Can you see how it's lower? The thinner it is, the lower it is. That's because it's evaporated quicker. And so if we give it enough time, these ones will also get down to like 1 or 2 ohms each. Not 100% dry yet, but I'm gonna put this back together, and I think we'll find that it should work. As long as there's no other degradation elsewhere in the keypad, like there could even be some up under here, I just don't know. All I know is that I measured it down here and we could visually see it as well. So anyway, so hopefully we fix that. So hang on. Oh, I haven't put the little there's little clips in there that sort of like hold it in place, but anyway, we'll put this back on here for now and we'll see if we can get it working. Boom, that's the top row. Top row, yes, yes. And then this row here, yes, 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 and yes. There you go. Winner, winner, chicken dinner. There you have it. That should work a treat, assuming that the receiver on the other end works. No worries. So there you go. That was an interesting repair. I did not expect that, and that's something that I'm struggling to remember where if I've actually seen that sort of degradation in the silver. It's like they have done like a silver roll paint on the thing. Like it's not like a copper, you know, traces or anything like that. It looks like they've done a silver paint on there, and for some reason, without it flexing, without it actually being part of some flexible thing, it's Kamagutsa, and it's worn off, and not just in one spot. It had worn off on like 4 of the rows like that, and this one here was borderline like intermittent as well. The columns seem to have been okay, but I redid the columns anyway. But yeah, all of the rows were just Gonski, the silver, and it looked perfect from one side. It looked fine, like there's nothing wrong with it. Yet you flip it over and you can see the degradation on the other side against the plastic. So maybe some weird chemical things going on there. I don't know. If you've seen this before and you know exactly, if you're a chemist, you should ask Mrs. EEVblog. She's a chemist. Anyway, yeah, some sort of weird thing happening there. It looked fine on one side, and yet the other side, you can see it was clearly degraded on those lines. So silver paint for the win. You probably should have some of this lying around. And yeah, there were some suggestions that maybe, because I did a live showed this, that maybe I could rejuvenate this sort of stuff because the silver's still in there, maybe with some acetone or something like that, perhaps. I don't know, but this still seemed to actually work, so kinda, sorta. But anyway, yeah, groovy stuff and an interesting fault. Hope you liked that. If you did, please give it a big thumbs up. As always, discuss down below. And happy wife, happy life. Catch you next time.